Everybody. Now, 1 past noon. Today is Monday, 26th of April, the last week of April. Next week is going to be May. Today, my main point, I'm going to talk about, textbooks. Some student asked me, of course, what the textbooks that I used for my study. That's 14 years, 7 years in Thailand in science, physics for bachelor degree and master degree, and another 7 years in the States, that's the engineering. Somebody asked me what the difference between science and engineering. Well, for science, talking about scientists, try to come up with new theories. So you have to prove some new theories, and for engineering, they're going to apply that theories to implement some like device equipments for human, for better life. So you create new tools, you create new equipments, you do some structures, you name it. So theories and implement. Okay, starting from, actually I have more textbooks than what you see here on my table here. I've been working since this morning in front of my computer, so I have to take a rest of my eyes. So it's better opportunities for me to video and talk in general about a textbook. Well, start from undergrad or bachelor degree. I study physics at Prasan Mid University. This is the introduction to solid state physics. Let's go through quick about topics. I study crystal structure, reciprocal lattice, diamagnetism, and paramagnetism, ferromagnetism, and anti-ferromagnetism, magnetic resonance. So it's there. Also about equation, I study Fermi-Dirac distribution function, Boltzmann's transport equation. Of course, I not really remember everything. Sometimes, I open, the textbook. I'm kind of surprised what I've been through. You ask me, can I remember? Now only maybe 20% that I remember. But since you already been through materials, just take a look quick to do some searching, whatever you're looking for. Of course, I also study electromagnetics. Something about engineering, I study about digital, of course, circuits, as well. Study math for physics. That's the four of them: math 1, math 2, math 3, math 4. And I got a good book. This is very old one, but it's very useful. It's about mathematics handbooks, from Outline series. You should have it. It's give you about integral of trigonometry, talking about differential equation, talking about Poisson equation. It's just a like Bible. I still use this one. Okay, and then I also study nuclear physics, but not really used now. And after that, I continue my study for master degree, the same major, physics, at Chulalongkorn University. That took 3 years. And of course, it's getting more difficult because you went to study at one of the top university in Thailand about physics. We have taught by Thai outstanding scientists, mostly like scientists. So of course, about assignments is so tough, TOUGH, or difficult, very, very difficult. And what else? We have our homework assignment. You don't have to talk about our, exams. It's very difficult, very tough. This is the book. In Thailand, you can make a copy of the book, but in the States, you cannot do that because people will look down at you. It doesn't mean it's illegal, but it's not appropriate, to do that. So mostly you can see that we have a hardcover, so it lasts long. You can use, for a long time. This one is about physical properties of semiconductors. Let's get back about my research or my dissertation. What did I do? The topic is about high temperature superconductor. Many people are wondering, what is the superconductor? Well, by the name, conductor means it's conduct current, and super means it's very conduct, a lot of current. Superconductor is we're talking about in general materials. They have resistance. The resistance is not zero. That means you will lose some power because the power will drop, across resistor. Sometimes it dissipates in the term of heat, and that you will lose power. But superconductor means you have a resistance become zero. Power loss. You have 100% input power. You have 100% of output power. So that's what we are looking for. But the problem is that we have to cool down that materials. Very, very low temperature. Sometimes it's like 0 Kelvin below that, or negative or 273 degrees Celsius, right? So that's why we put the topic. That's one is the high temperature superconductor. That means we try to create superconductor not too low temperature. Try to make it happen at room temperature, but that's not possible. But we just get like higher temperature to create superconductor. So that's about the brief, the term of our superconductor. Okay, this one is physical properties of semiconductors. The topic is there are so many here in general. We have our study crystal property, energy bands, crystal imperfections, equilibrium, distribution, transport property, scattering processes, optical properties, excess carriers, heterostructure, surface structure. And this is our later on when I went to study in the States in engineering. The first one is the master degree in microelectronic manufacturing. I did the process to make a very, very small integrated circuit. Just you can see here the chip, right? Your smartphone, everywhere, electronics, equipments, electronic devices. This one is physics of engineering materials. We have study quantum theory, statistical wave function, atoms and bond, theories of solid, thermal properties of solid, electrical conductivity, thermoelectric and galvomagnetic effects. See, I still forgot since I become an engineer. Now what I've been teaching is I was teaching junior lab, sophomore lab, and microelectronics manufacturing course, that's for seniors, and also electronic packaging systems, that's also for elective course for senior. Factors affecting the properties of semiconductors, basic semiconductor devices, magnetism. The other one, physics of semiconductor devices. Of course, I also study electromagnetics. About electromagnetic, I studied since like undergrad through my Ph.D. So I study about electromagnetics a lot. Physics of semiconductor devices. What I study, let's see the topics. This is focused on our semiconductor, basic semiconductor physics, p-n junctions, Scotty barrier junctions, heterojunctions and ohmic contacts, bipolar junction transistor. Actually, I studied that when I study engineering. I also focus on semiconductor devices, but actually I studied that for my master degree in physics before, so it's some kind of repeat, but that's more likely science, not engineer. Bipolar junction transistor, field effect transistor, photonic devices, transfer electron devices, and avalanche diodes, transistor structures. That's about our physics of semiconductor devices. And this one is about our electromagnetics. Well, what the difference between when I study electromagnetics in the science program and engineering program. For science program, electromagnetics mostly focus on a lot of equations. So you have to study about green function. I also, for my master degree in physics, that's theories. I use green function to do some calculation for high temperature superconductors. For this one, classical electromagnetics, introduction to electrostatics, battery value problems in electrostatics, battery value problems in electrostatics 2, multiples electrostatics of macroscopic meter dielectrics, magnetostatics, time varying fields, Maxwell equations, conservation laws, plane electromagnetic waves, wave skies and resonance cavities, simple radiating system in diffraction, magnetohydrodynamic and plasma physics, special theory of relativity, like Einstein, right? Relativistic particle kinematics and dynamics, collisions between charged particles, energy loss and scattering, radiation by moving charges, Bremer-Trarang method of virtual quantum radiative beta processes, multiple fields, radiation damping cell fields of particle scattering and absorption of radiations by bound system. So that's our classical electro dynamics. That's for master degree program in physics and science. After that, I moved. I took a break for 1 year. I worked at Seagate company as the failure analysis engineer. Work on a hard disk. Before this, the hard disk is very big, not just like today. It's getting much smaller. And then after I got a scholarship, I went to study for master degree and Ph.D. And the scholarship gave me, what, 5.5 years for the scholarship. But I was there about 7 years. For the last year, I got a scholarship from the department, State University of New York at Binghamton, New York. Well, when I went to because I switched the program from science to engineering, I have to take a prerequisite course. So I need to take undergrad courses. Back again, even I study semiconductor at Chulalongkorn University for my master degree in science, I still have to go to study semiconductors fundamentals, p-n junction diode. This one is cost like $17 US. You multiply at the time by 25. Okay. You can do your own calculation, and this one 17 US. The topic, talking about semiconductor device, general information, carrier modeling, carrier action. Volume 2. You study introduction to diode, p-n junction statics, the ideal diode, 4 ampere characteristic deviation from ideal diode, p-n junction admittance, switching response, mirror semiconductor contacts. So this one, and I study microelectronic manufacturing 1, 2, 3. That's there also study about Six Sigma, and that program at Rochester Institute of Technology, the first master degree that I've been through, I'm happy about it because it's just like you're working in the factories. You hand-on. That means you work on machines, you create some devices, but that's pain in the neck because for when you study in the class, you have to go to the lab. That takes another 3 hours. And the problem is that because I'm not get used to some technical terms in engineering, so you have a difficult time to understand about what professor tried to explain. You have to operate machines. You have to do doping, p-n junction. You have to do lithography. You have to do contact. You have to do ion implantation. You have to put your SMOC or your ground, in the white suit, go into the clean room with the mask, on, because they try to avoid some defects or some particles, because the integrated circuit, you're talking about the size in a micrometer or 1 in a millionth of meter. So it's very small. Even a small particle cause some problems. If you have defects, or your device will fail. And I've been through very, very difficult time. Study microelectronic manufacturing, but I learned a lot. Just like you be working in the factories. That took 2 years. And I also have to study chemistry, as well, because you have to work on some materials. You have to understand, deep inside of materials to be able to work with the process Otherwise, you will make mistake. Everything you do, you need something to back up. You're not just like hit or miss. You need to be able to explain. That's for master degree. And sometimes you have to been through about 60 processes to be able to get a CMOS, NMOS, PMOS transistor or integrated circuit. But it's just like circulate. You have about machines, you have to do different, maybe 20 steps, 20 machines, but it's going to be a circulate because you have to repeat some of your steps because you have different layers of the device. And after that, I moved to University of Rochester in the same city, about 3 kilometers from RIT, the first university that I studied. Thus I get a master degree in electrical engineering, but actually it's about electronics. I work on superconductor. And that took 2 years, but I have to move because we have some problem with the budget of to do research. And that's when I got the master degree. Since I finished my work, so they gave me a degree. And after that, I moved to. See here I have the book that I used. Oh, sorry, I skipped. Let's get back to the first master degree, the book that I used. This is just like Bipolar, silicon processing, VLSI era for your one. This one costs $60, $60 US. You multiply by 25, and this one's even more expensive. This one is $90 US, $90, hardcover. But is there explain details about different processes to be able to complete your integrated circuit to complete NMOS, CMOS, filled with their physics background, filled with their chemistry, some many equations, of course. But I'm not really, working on this one yet. I mean, try to, do that in time. But I'm not really spend a lot of time, on that. And also, I want to mention about this one. I got it less than $50 US. Is the art of electronics for electrical engineering, electronic engineering, engineer. You should have this one. It's just like Bipolar. It's very good referenced by the name, the Art of Electronics, Cambridge University. We're talking about signal capacitor, inductors, Eber model, amplifier, field effect transistor, feedback and operation amplifiers. Talking about active filters and oscillators, voltage regulators and power circuits, precision circuits and low noise techniques, digital electronics, of course, digital meets analog, microcomputers, microprocessors, electronics construction techniques, high frequency and high speed techniques, low power design, measurements and signal processing, or DSP, digital signal processing. So it's a very good book. Just have a total about, let's see. So we have our appendix. 1,000 72 pages, and that's not expensive. That's the fair price. But you need some background to be able to go through, the art of electronics, because it's deep in about explanation, not so many equations, but it's give you the idea, it's give you principles, for you when you want to work on electronics. As I mentioned, even have a schematic for DC power supply. So you study hard, you probably be able to understand. But it's good for graduate student, because for undergrad student maybe you have a difficult time to go through, especially if your English is not good. Okay, that's the second master degree in electrical engineering. And then I moved to State University of New York at Binghamton. That's about 3 hours, from Rochester down to the south. We call upstate New York, Rochester and Binghamton. And from Rochester go to New York City. That takes about maybe 6 hours. And New York City actually is not the capital of New York State. Many people, get it wrong. But the capital of the New York State is the Albany, Albany, and that's have a very good university named RPI, not RIP. RIP is rest in peace. Rest in peace. When somebody passed away, you put like RIP. But RPI stands for Rensselaer Polytechnic Institute of Technology, one of the best university in the States. That's the capital of New York State, and not a big city. Compared to Rochester, Rochester is bigger, and you know that I call it industrial city because you have a Bosch & Lomb, right? You have Ray-Ban, the sunglasses. You have contact lens. You have Xerox, the copy machine, right? And many people got it wrong. Like, hey, I want to go Xerox, lecture notes of Professor Cook. Maybe you got the name is copy is the verb, right? Maybe it's the first copy company. So that's why I used to remember when you want to make a copy, you go Xerox. But now it's, I'm not sure it's still in the business or not. But Kodak, Kodak, is there no more business. It's a very good company. So that's why I call industrial city. So I moved to New York State University at Binghamton for my Ph.D. And that's when I work on single electron transistor. It's their theories. It's not. It's practical. So I work on MATLAB. I have my dissertation, 5,000 lines of MATLAB to do simulation of a single electron transistor. Use the Boltzmann distribution. I won't get into that. Let's move to talk about what I want to focus is about the textbook that I use. Over there, as I mentioned, I spent 3 years over there. 2 years at RIT, 2 years at the University of Rochester, and another 3 years at the Binghamton University. Oh, actually, University of Rochester, I still have to go through, study logic design. we have a lot of assignment, a lot, but we also learn a lot too. Okay, I dropped my textbook down. Oh, that's okay. Well, when I went over there, what textbook that I used, I have to study fusion waves or electromagnetics again. The book that I use is named Fusion Waves in Communication Electronics, and mostly about electromagnetic study, electromagnetics of circuits, transmission lines, plane wave propagation. Of course, transmission line, you also go through a Smith chart, right? To do many calculation to do a transmission line matching. So that's mean a transmission line matching. Well, you have transmission line, you send a signal, right? Input, and at the end of your transmission line, you have load. It can be a capacitor, can be a resistor, can be inductor. You don't want the signal reflect back to the source or the input, because it will distort your signal. You want the transmission coefficient to be 0, so you get you have no distortion at the load. That's what you expect, and you use the Smith chart to do the transmission line matching. Plane wave propagation and reflection, 2 and 3 dimensional boundary value problems. Waveguides with cylindrical conducting boundaries, spatial waveguide types, resonance, cavities, microwave networks, radiation, electromagnetics property of materials, optics. That's about electromagnetics. And this class, taught by a Chinese professor, Chinese American professor. The funny thing is that we have homework for 50% out of the final grade. So we work in group. That's why I met my friend Dan. So we hang around together, improve my English. We went out for shooting. He bought me a rifle, .21, and he had a shotgun. We went out to the forest to do the shooting. And also he took me to do a safety class. I mean, to learn how to use gun before go out hunting, and you can get a certificate for hunting license. If you not pass this course, that took about like 6 hours. They give you ammunition for free, and then you can get a certificate. But we're not never out for hunting. And again, that's we went out together. It's difficult to make friends, American friends over there. But if you work together about homework assignments, become close friends, and we get along fairly well. And electronic properties of materials. Same thing. Have fundamentals of electron theory, wave particle duality, Schrödinger equation, solution of Schrödinger equations for 4 specific problems. Energy bands in crystal, electrons in crystal, electrical properties of material, electrical conduction in metals and alloys, semiconductors, electrical conduction in polymers, ceramics, and amorphous materials, optical properties of materials, optical constant, atomistic theory of optical properties, quantum mechanical treatment of the optical properties, magnetic properties of material, foundation of magnetism, magnetic phenomena and their interpretation, classical approach, quantum mechanical consideration, application, thermal properties of materials, fundamental of thermal properties, heat capacity, thermal conduction, thermal expansion, That's about electronics property of materials. This one costs the used one. I mentioned about it before. $36. Analog and digital communication systems. I also study on that. Actually, in University of Rochester, I also study DSP, digital signal processing. We're talking about a filter, butterfly filter. The topic: signal analysis, linear system, probability and random analysis, amplitude modulation systems, frequency and phase modulation, pulse modulation, digital communications, information theory, and coding. That's about our analog and digital communication systems. Of course, you study electrical engineering, you cannot get away from devices. So this one is bipolar semiconductor devices. I actually have also CMOS book, but I gave to one of our professor in the electronic departments, KMTL, Professor Varagon. I think it's more useful for him, to have that. Topics: overview of basic semiconductor properties, PN and N plus junction, PN junction diodes, transient and high frequency behavior of diodes, structure and theory of practical diodes, photodetector diodes and solar cells, bipolar transistor, basic structure and theory, analysis with real impurity profiles, the emitter, real impurity profiles, the base and collector regions, high current effect in bipolar transistor, transient behavior of transistor, discrete bipolar transistor structures, integrated transistor, advanced technology devices, numerical analysis and CAD model, bipolar transistor. That's about bipolar semiconductor devices. And for my 6 year in the States, I got a scholarship from the department because the government not support me anymore. So I'm lucky that got a scholarship. I don't have to pay for tuition. They pay me about $800 per month to do the teaching assistance. My responsibility, I have to take care of junior lab. This is the junior lab, the manual. We have about 20 labs that I have to go through all of them, not just like here. We have only take responsibility of only one lab. Or I have to do my work first, to do homework before I go to class, because the American people, that they ask a lot. So you have to be prepared. I have, for example, the lab. What did they do over there? Let's see. They have many lab policy, but I'm not really go through that. We have a frequency component of a periodic wave, transformer equivalent circuit, pulse spectrum and impulse response, pulse on a transmission line, velocity servo control system, infrared LED and photo transistor, position servo control system, semiconductor PN junction, correct capacitance and resistance, power spectral density and power transfer function, ACR and triad, PN junction characteristic. There are more than that. Also have a voltage regulator, digital analog and analog digital converter, DAC, right? ADC. So if you have a lot, I have to go through the lab before I went to do the lab. And also I got assignment, to teach solid state electronic circuit devices. Same thing. We have a crystal properties, of course, and semiconductor atoms and electrons, energy bands and charge carriers in semiconductors, excess carrier in semiconductors, junctions, PN junction diodes, bipolar junction transistor, field effect transistor, FET, integrated circuit, lasers, PN switching device, negative conductance microwave devices, and The good thing is that it comes with the solution of the question at the end of each chapter. So you have solution. Actually, I put on my YouTube in topic semiconductor devices. I think it's about maybe more than 10 series. You can go back to that. So that's all about the textbooks that I use. If somebody curious about what the textbook I use when I studied for 14 years. Of course, I'm not remember everything, but I can go back anytime, for if I want to or study. Well, you don't have to study, a lot like this. Somebody not spend like 14 years, sometimes like 4 years as bachelor degree, right? And another 3 years for Ph.D. or you can still be able to do a good research. But for me, it's just my fortune. It's just my opportunity. Doesn't have to move on. And I'm not really, actually I talk to many students that are, when I finish high school, I want to be a doctor, I want to be an engineer, but I'm not good enough, so I cannot be an engineer. But with the my strong intention to move on, and finally I become professor at engineering, electronic engineering. So if you set up your goal, try to do it. Sometimes you success, sometimes you're not success, but at least you try. And that's I give encouragement to students. So be prepared. You don't know what's going to happen, but when you have your knowledge, whatever, you don't have to be an engineer, you don't have to be a doctor. Be something. You don't know what can happen. Who expect that COVID-19 is going to be here? And we don't know how long it's going to last, right? But if you have knowledge, you have something that you can move on with your life, make your life go on. You can do many things. You have options. You cannot do this, you switch to do something else. You have the alternate ways, to do. So it's my main point why I sit down here and put on the video, because I just want to explain about something. You have your experience. Why keep it, just talk it out, speak it out. Okay, so and I will talk about some out of campus activities, because somebody might get bored if I talk about academic too much. And we will talk about what out of university, out of campus activities that I did. Okay, take care everybody. Happy Monday. Now it's the 15 to 1. Time flies. I woke up today at 5 a.m. As usual, actually 4:30. Now it's almost 1 o'clock. And I will give you for senior student in microelectronics engineering, I will give you assignment, because we have no on-site final exam. You have to do assignment from home. I don't know how long it's going to last. I mean, COVID-19. The school actually closed until the end of April. That's mean this Friday, right? I don't know that will extend or seem to be like that. Today is the COVID infection is jumped close to 3,000, if I'm not wrong. I read news this morning. So keep track with that, and try to avoid get into a crowd. Try to be by yourself, and it's a good time for you to go through some material, to study, learn something. Don't waste your time. Okay, I'll be talk to you later. Again, have a good happy Monday and the whole week. Okay, bye.